Okay, next one. What are the basic properties we're going to use in this class? The first one we're going to introduce in this class is called specific volume. This is probably something new, but it's actually very straightforward. We use the letter nu, which can be spelled as nu. Nu is equal to volume over mass. That's the definition of specific volume. We use the letter nu, which can be spelled as nu. The definition of nu is volume over mass. Volume over mass. Okay, volume over mass may be something new to you, but what is mass over volume? Mass over volume is density. Exactly. Mass over volume is density. So what is actually the relationship between nu and rho? The nu is the inverse of rho. That's the definition of specific volume, nu. Next, what will be the unit for specific volume? We can easily tell the unit from the definition. Volume over mass. What is the unit for volume? Cubic meter. What is the unit for mass? Kilogram. So it's gonna be cubic meter divided by kilogram. That is the unit for specific volume. Okay, that's the first property we introduce in this class. The second one is molar basis. Everyone should have learned this in chemistry class. Molar basis. 1 mole. 1 mole is equal to 6.02 times 10 to 23rd molecules. And this number has a name. This number has a name. The name is Avogadro number. Avogadro number. Okay, and then molar number. Next one, molar number. What's the definition of molar number? We use letter N for molar number. N is equal to mass over molecular weight. We use MW for molecular weight. MW means molecular weight. Okay, then how do you find molecular weight? The definition of molecular weight is the number of the protons plus the number of neutrons. Okay, so now let's do a quick example. We have oxygen, we have nitrogen. Those are the two biggest components in air. Usually, let's say oxygen takes up 20% of the air, and then nitrogen, we say 80% of the air. So in total, that is 100%. And next, what is the molecular weight of oxygen? What is the molecular weight of oxygen? So let's take a look. Oxygen. Oh, if you go to the periodic table, you can find oxygen has 8 protons and 8 neutrons. So in total, 8 plus 8, that's 16. So that is the molecular weight for O, for one O, which is 16. However, for oxygen, how many O's do you have? You have 2 of them. So 16 multiplied by 2, that is 32. Okay, and don't forget molecular weight. Molecular weight has a unit. The unit is gram per mole. And then you can do the same thing for nitrogen. What is the molecular weight for nitrogen? You go to the periodic table and you look up nitrogen. It has 7 protons and 7 neutrons. In total, that's 14. And again, that is only the molecular weight for one N. For nitrogen, the gas, you have 2 N's. So you're going to do 14 multiplied by 2, which is 28. The unit again is gram per mole. So those are given conditions. And then what we want to find is the molecular weight of air. How do we find the molecular weight of air? Molecular weight of air. Like we said, air is a mixture of oxygen and nitrogen, where oxygen takes up 20% and nitrogen takes up 80%. So each component contributes a little bit to the molecular weight of air. So of course, the molecular weight of oxygen, let me quickly erase that. The molecular weight of oxygen will contribute a little bit, and plus the molecular weight of nitrogen will also contribute a little bit. How much does each one contribute? Oxygen takes up 20%, so it's going to contribute 20%. Nitrogen takes up 80%, so it's going to contribute 80%. So this is how you calculate the molecular weight of air. All right, so because we have the molecular weight of oxygen, which is 32, we just plug it in. And then we also have the molecular weight of nitrogen, which is 28. Just plug it in. And then the solution is 29. And the unit will still be gram per mole. Okay, so our solution for the molecular weight of air is 29 gram per mole. What have you noticed? 29 is very, very close to 28, and 28 is the molecular weight of nitrogen. Why our solution is closer to nitrogen than to oxygen? Because nitrogen takes 80%, which is dominant, right? So if nitrogen is dominant, our solution must be close to nitrogen. That's why the solution is 29. Okay, very, very close to 28. Okay, and then let's do another example. We have 1 kilogram of air and its molecular weight is 29 gram per mole, which we just discovered from the previous example. What we want to find is molar number and the number of molecules. Solution part 1, molar number. Molar number. We use letter N for molar number. And if you can recall the definition of molar number from before, molar number is equal to mass over molecular weight. Do we have the mass of the air? Yes, we do, which is 1 kilogram. Do we have the molecular weight of oxygen? It's given. Do we have the molecular weight of air? It's given. It's 29 gram per mole. So it's actually very easy. What you need to do is just plug and chug. But there's one thing you have to be careful about, that is the unit. Okay, so what we can do is to convert 1 kilogram to 1000 gram divided by 29 gram per mole. And then the 2 grams will cancel each other. The solution will be 34.48, and then the only unit that is left is mole. Right? It's 1 over 1 over mole. So the solution is mole. Okay. All right, so that's part 1, the molar number. Part 2 is the number of molecules. I have the molar number now. I'm looking for the number of molecules. How do we do that? Yes, we need to use Avogadro number. If 1 mole means you have this many molecules, 34.48 moles must mean you have how many moles? It's very easy. Number of molecules is equal to molar number, which is 34.4 multiplied by the Avogadro number, 6.02 times 10 to 23rd. And solution is 2.07 times 10 to 25th. This is how many molecules you have. Okay, so that's the second one, second property, which is molar basis. And then after that, we introduce the third property, which we use a lot in this class, and that is pressure. That is pressure. What is the definition of pressure? Pressure is defined as force over area, and we use P for pressure. Okay, so now what is the unit for pressure? The unit for pressure from the definition is, what is the unit for force? It's Newton. And what is the unit for area? Meter squared. So Newton divided by meter squared. That is the unit. And it's equivalent to Pascal. So Pascal is the SI unit for pressure. It is equivalent to Newton divided by meter squared. Okay, so now when we measure pressures, you have two options. Let's say this is where the pressure is, and this is your reference point. If you choose complete vacuum as your reference, and then you measure the pressure, you can call it absolute pressure. We use P with a subscript of ABS to indicate absolute pressure. And then you have another choice. This time you do not use complete vacuum as your reference. This time you choose the atmosphere as your reference. Atmosphere is about 1 atm. It's higher than complete volume. And now if you choose atmosphere as your reference, this time the pressure you measure, we call it P pressure with a subscript of gauge pressure. Okay, and here is the pressure of the ATM. ATM meaning atmosphere. So now can you find out the relation between the three pressures? Pressure of the absolute pressure is equal to gauge pressure plus pressure of the atmosphere. How do you understand this? We can use one analogy. You can think of the complete vacuum, the bottom line, as the ground floor, and think of the atmosphere, the second line, as the second floor. That's where it's standing. Okay, I'll draw a pair of shoes. Okay, does it look like shoes? All right, shoes. Okay, you are standing on the second floor, which is the line representing atmosphere. And then this is where your head is. Okay, when I measure how tall you are, I have two options. I can choose to use the vacuum, which is the ground floor, as my reference. And then I go to the top of your head to measure how tall you are. That is similar to absolute pressure. The second option that I have to measure how tall you are is to start from your feet, which is similar to the line representing atmosphere, and then go to the top of your head. And then the height I measure is similar to gauge pressure. Okay, so the only difference is just what the reference you choose when you measure the pressure. If you choose vacuum, then your solution will be absolute pressure. If you choose atmosphere, then your solution will be gauge pressure. Okay, all right, so next one. Next one is the units. So we know the SI unit for pressure is Pascal. We also have kilopascal to use. We also have bar to use. Then we also use megapascal. And now we need to convert each one of them to SI unit. Kilopascal is equal to kilo. Kilo is 10 to the third Pascal. Bar. Bar is equal to 10 to the fifth Pascal. And then the last one, mega. Mega is 10 to the sixth. Okay, so that's the conversion of the units. And then last one, pressure of the atmosphere. What is the pressure of the atmosphere in Pascal? It's a constant, 101325. That is the pressure of the atmosphere. Okay, so that's the third property we introduced in this class. And then the last one is temperature. The last one is temperature. Okay, temperature is pretty easy. And then the only thing we need to discuss here is the units. Generally speaking, there are three units for temperature that we use. The first one is Fahrenheit, which we use in our daily life. And the second one is Celsius, which is used widely in the world. And then the last one is Kelvin. The last one is Kelvin. And which one is the SI unit for temperature? The SI unit for temperature is not Fahrenheit, is not Celsius. The SI unit for temperature is Kelvin. Kelvin is called the absolute temperature, meaning the lowest temperature in terms of Kelvin is 0 Kelvin. There's nothing below 0 Kelvin. Okay, so now we just take a look how to convert the units. So for example, if I start from Fahrenheit, how do I convert Fahrenheit to Celsius? Fahrenheit minus 32 multiplied by 5/9. And that will give you the temperature in terms of Celsius. This is how to convert Fahrenheit to Celsius. And then you can do the same thing. How do you convert Celsius to Fahrenheit? 9/5 multiplied by temperature in Celsius and then plus 32. And then the last one, how do we convert Celsius to Kelvin? This one is very straightforward. What you need to do is just to add Celsius by 273, and then that you will find the temperature in Kelvin.